I don't. Oh. Do you guys have an RV? Do you have a dog, Elizabeth? What did you say? No, my dad doesn't like them. That's sad.
All right, everyone. Well, welcome to Kitchen Chemistry, Week 6. It is hard to believe that we are here in Week 6. That means we are more than halfway. I'm going to send a quick poll to make sure that everyone can hear me. Go ahead and just click yes or no. Can you hear me? Okay, well, here we are in Kitchen Chemistry Week 6. Unfortunately, this week, my web camera is not working, so you will not be able to see me. However, I'm going to ask some of you to have your cameras be up on screen so that we can see each other. This is a great time for you to volunteer and get your face out there and for us to see how each other does some of the experiments. Last week, we made crystals for homework using borax. What I would like to do is if anyone would like to share their crystals with me. I know some of you sent me some fantastic pictures, but now is the time for you to live share. So Shelby, your hand is up. I'm going to turn your camera on. Go right ahead and let us see your crystals. Click the start button underneath the video. Shelby, we can see your snowflake, but we can't hear you. So go ahead and try to hit the talk button.
Well, my jar also had crystals when I took this out. And this is my snowflake. I don't really like to touch it. It's weird. And that's it.
Awesome job. Thank you very much for sharing, Shelby. Would anyone else like to? All right, Xana, you're next, and then Ian. Go ahead, Xana. We lost Xana, so Ian, go ahead. You're up. Click the start button underneath the video screen. Here you come. All right, great job. Thank you, Ian. Okay, who else would like to share theirs? Brianna, I don't see you having a video camera. Go, Brianna, to the bottom left-hand side of your screen to where you have orange wrench. Click on it, click Camera Settings, and then go ahead and choose the correct camera. While she is trying that, Elizabeth, you can go ahead and turn on your camera.
So this is my crystal. And as you can see, there's nothing very special about this crystal because you see this, I can just get a hold of it. There's this little piece sticking out. See?
All right, thank you very much, Elizabeth. Okay, does anyone else want to try and show their camera? Brianna, I still do not see a camera on your end. Brooklyn, did you want to share? Anyone else? Okay, fantastic. Well, those were some great crystals. That is one of my favorite labs to do. I think the crystals grow really quick. And the neat little side thing you can do with that is take a magnifying glass if you have one at home, and you can break a little crystal off of your snowflake or look at your whole snowflake underneath the magnifying glass, and you'll be able to see all the different shapes of the crystalline structure. We now are going to totally switch gears from crystals to acids and bases and pH. Something we have not talked about at all, and something I'm curious what you know about acids and bases and pH. So if you take a look at your whiteboard right now, make it large. I just made 2 rectangles up there. Above the first rectangle, I'm going to write the word acid. Above the second rectangle, I'm going to write the word base. What I want you to do is fill in anything you know about acids and bases. Xana, while people are starting on that, if you have a question, go right ahead. Go ahead, Shelby, you have a question? Uh-oh, part of my rectangle went away. Let me fix that.
I don't know anything about gum. I don't know anything about gum.
That's fine. It's okay to not know anything about them. That's why we're in this class. If you don't know anything about them, just don't write anything up here for right now. And hopefully, by the end of class, you will know something and you will be able to draw it up here. Now, if who's ever drawing on the board, I'm going to freeze everybody. When we write on the whiteboard, which everyone just got frozen, what we need to do is there are only 2 ways for you to write. The first way is a pencil that I just drew an arrow to. And the second way is this letter A. Oops. Is the letter A. If you want to type, you click on that letter A, put it on your screen, and you type. I am typing a word. Please do not draw squares or squiggly lines all over the board. It makes it very distracting for everybody else. I'm going to unlock the whiteboards one more time. If you know anything about acids or bases, please put it up here. If you don't, that is perfectly fine. That's why we're in this class. And you do not need to write anything because hopefully by the end of class, you will be able to add something to our board. So your whiteboards are now unlocked. Please use them responsibly. We will try one more time. I cannot tell right now who is writing on the board and making the squares. If you're doing it by accident, please stop. I can, however, tell at the end of class. You can now write on the board again. Please only write. Do not draw squares. Okay, well, there's some great information up here. It looks like someone is going to type. Okay, Brooklyn, I'll go ahead and add that under here for you. Thank you. Trouble typing on the whiteboard? You can go ahead and put it underneath the text chat, and I can add it up there for you. It is difficult to write on sometimes. I definitely agree, Brooklyn. So we have some great things up here. We have that acids have a high pH, lemons and vinegar. We have oranges underneath acids. We have bases have a low pH with baking soda, dish detergent, and borax. So now we're going to take a trip and we're going to see which of these are true, if any of them, which of these are false, if any of them, and then we are going to do a little experiment right now so that hopefully you can understand this better. So if we go ahead and look at your PowerPoint screen right now, it says acids and bases. They are everywhere, in your food, in your house, even in you. So let's take a look. Would anybody like to read this slide about acids? Shelby, go ahead.
What is an acid? An acid is a solid that has an excess of H plus ions. It comes from the Latin word exercitus that means sharp or sore. The more H plus ions, the more acidic the solution.
Awesome, great job. So everybody should be on the PowerPoint screen, which is the top right screen. And you should see a picture right now that says, what is an acid? So thank you very much, Shelby, for reading that. And basically, an acid is a solution. Well, that's kind of a big, what is a solution? Solution is a mixture of a liquid and another liquid, a liquid and a solid, liquid and a gas, a mixture of something. So, for example, when I make hot chocolate and I mix the cocoa powder into my water, that's a solution. If I have a sore throat and I decide, oh, I'm going to gargle some salt water, so I mix some warm water and salt, that is another solution. So an acid is a solution that has an excess of hydrogen ions. Well, that's a little higher chemistry than what you're going to do right now. Right now, what's important for us is just to be able to recognize acids and what acids are. Not necessarily all the crazy chemistry behind it. The word acid means sharp or sour. Basically, the more hydrogen ions there are in a solution, the more acidic the solution is. For example, some acids are coffee, tomato juice, orange juice, lemons, or in your body, gastric acid. Some properties of an acid. There's a little picture here, or diagram on the left, and then I listed some properties here on the right. Acids are found in our everyday life. Xana, do you have a question for me?
Ma'am, we cannot see anything the PowerPoint screen you wanted us to look at. We could not see, and it keeps logging ourselves out.
All right. Let me send a quick poll out. Is anyone else having trouble seeing the PowerPoint? If you're having trouble, click yes. I think it may be an unstable connection for Xana and Brianna, but what I'd like to do is I'm going to go ahead and log out and make sure it's nothing on my end. You guys are probably all going to have to do the same thing. So I'm going to log out right now. If you could wait about 10 seconds, log yourselves out, and then back in, that would be fantastic. And hopefully okay, I am back in. I'm hoping that will fix their problems. Thank you all for being accommodating to that. And we'll try it and we'll see if it works. So I'm just going to check, can you hear me and see my PowerPoint on my screen? So if you could go ahead for me and let me know if you can hear me and see my PowerPoint on my screen. Go ahead, Xana.
We can hear you, but we cannot see the PowerPoint screen.
Yeah, let me see if everyone else can. If everyone else can, I really think it's a connection on your end. But let me see. Okay, if you could just click yes or no for me one last time. Thank you all for being so willing to cooperate. And just let me know if you can see my PowerPoint screen. Okay, the majority of you can see it, so I'm going to go ahead and continue. I believe it is a problem on your end, Xana. So you can go ahead and follow along verbally, or this PowerPoint is up on the Moodle site if you want to go grab it from there and follow along from there. So we have the properties of acid listed here. We have on the left-hand side a diagram, and on the right-hand side just a bulleted list of properties. Acids in general, and these are all generalizations, taste sour, tart. Think about when you taste a lemon, what it tastes like. Now, let's remember, we are in a science class. We do not taste things unless I specifically tell you you can. We are not tasting anything today. But you know what lemons taste like, probably. So that's what an acid would taste like. Acids conduct electricity. Acids are corrosive, which means they break down certain substances. Many times acids can corrode, which means to make a hole in fabric, skin, or paper. Think about this. If you have battery acid that your dad maybe is working with in the garage, he might say, be very careful, this battery acid will put a hole in your shirt. It's corroding the shirt. My husband has done that. He's come in and there's holes in his shirts because he's spilt acid on them. So you need to be very careful with acids. Some acids react very strongly with metal. And acids, you can test for them because they turn the blue litmus paper red. So those are some general characteristics of acids. Vinegar is an acid. The acid that's in vinegar is ethanoic acid. Colas, Coke, Pepsi, those have acids in it. Those have carbonic acid in them. Tea, that maybe your mom or your dad or a grown-up friend drinks, has tannic acid in it. Vitamin C, which is very healthy for you, has ascorbic acid in it. And lemons have citric acid in them. So what can acids be used for? Well, acetic acid is vinegar. You can clean lots of things with vinegar. You can clean your hard floors with vinegar. Citric acid, lemons, limes, oranges, is used in a lot of sour candies. Raise your hand if you like lemon heads or Sour Patch Kids. Or give me a smile face, whichever is easier for you. If you like lemon heads, Sour Patch Kids, raise your hand or give me a smile face. A few of you. So you like citric acid. For me, I agree with you, Ian, a big frown face for me. I do not like Sour Patch Kids. I would much rather be eating a Hershey's chocolate bar. Ascorbic acid is another acid. Ascorbic acid has vitamin C, which your body needs to function. Sometimes if you feel like you're getting a little bit of a cold, ascorbic acid and vitamin C can help your body fight that cold naturally. Sulfuric acid is a type of acid that's used to produce fertilizers, steel, paints, and plastics. And there's also acid in car batteries. So let's think about a base. What is a base? Would anyone besides Shelby like to read this for me? All right, we're going to have Mallory read it. I'm just going to tell you, Mallory, where it says OH, you can say hydroxide. Okay, so Mallory, go right ahead and read me this slide.
What is a base? A base is a solution that has an excess of hydroxide. Another word for base is alkali. Bases are substances that can accept hydrogen.
Great job. Thank you very much. So that's the chemistry behind it. What is a base? We said the acid has extra or excess hydrogen ions. Well, a base has an excess of hydroxide ions. Hydrogen and hydroxide ions are opposites of each other. So an acid and a are sort of like opposites of each other. Another word for base is alkali. And bases are substances that can accept hydrogen ions. So that's all good, but it doesn't really mean much. So let's learn what a base is. Bases tend to feel slippery. They taste bitter. They can be corrosive, just like an acid. They can conduct electricity. Think alkaline battery. That's a base. But bases do not react with metals. And they turn red litmus paper blue. Here's a couple of pictures of bases up on your screen. We have Drano to clean your drains. We have oven cleaner to clean all the hard, crusty stuff in your oven. We have ammonia in the back and baking soda in the front. Does anyone see a pattern with these four bases? Brianna, what do you think the pattern may be?
That they all are the same thing.
They're not really the same thing, but you can use all four of these to do something. Maybe your mom does it around the house. Oh, good job, Elizabeth. Bases are mostly used in cleaning. Times Dad does it, but in my house, it's usually me. So here's some uses of bases. Would anyone different like to read this one? Brooklyn, go right ahead.
Bases give soaps. Mom, what's this word? Ammonia and many other cleaning products. Some of their useful properties: the OH ions interact strongly with certain substances such as dirt and grease. Chalk and oven cleaner are examples of familiar products that contain bases. Your blood is a basic solution.
Thank you very much, Brooklyn. Great job reading. So here's a picture of something called the pH scale. So we have acids, we have bases, and we have something in the middle. That something in the middle is called a neutral. Here are some examples of common household items and where they fall in the pH scale. The pH scale tells us how acidic or how basic a solution is. acidic solutions have pH values below 7. So if we look at this picture, or the diagram, an apple has a pH value of a little more than 3. So it is an acid. Soap has a pH value of 10. That's more than 7, so it is basic. And at 7 exactly is pure distilled water. Here's a little question about reading this pH scale. So here we go. What is baking soda? An acid or a base? So the first thing you're going to do is you are going to find baking soda on the pH scale. If it is above 7, it is a base. If it is below 7, it is an acid. So is baking soda an acid or a base?
Cleaners.
Okay, a baking soda is a base. Good job. We're going to try one more, but I'm not going to talk you through it as much. You are going to have to do this one more on your own. Okay, what is milk? Is milk an acid or a base? Think about it. Find milk. Is it an acid or a base? Okay, we're going to talk through this a little because I got lots of right answers and lots of wrong answers. So, if we look on the pH scale here, raise your hand if you can tell me about what the pH of milk is. What do you think the pH of milk is? Shelby, go ahead.
Base.
Okay. Okay, we're not going to get to that part of the answer. You need a number first. What do you think the pH number or the pH value of milk is? I'm looking for an actual number, like 1, 2, 12. What is the number for milk? Anyone want to give that to me? Brianna, go ahead.
7.
It's between 6 and 7. If you look at the diagram, the arrow for milk is somewhere between the number 6 and the number 7. So, I'm going to just say 6.5, just to give it a number. So, 6.5 6.5, is that below 7 or above 7? What do you think? Who wants to help me out? Is 6.5 above 7 or below 7? Xana, go ahead.
Below 7.
Awesome. 6.5 is below 7. So now we are going to think about this and read my slide. In a solution that has a pH below 7, is it acid or is it a base? Raise your hand if you want to help. 6.5. Mallory, go ahead.
Acid.
Awesome. 6.5 is below 7, which makes it an acid. All right, I'm going to give you one more. Let's see if we can get 100% on this one. Let's find soap. What is soap? An acid or a base? Go through the steps just like we just did. Oh, sorry, hold on. I hit the wrong button. There we go. Go through the steps. Is soap an acid or a base? Awesome. I got 100% on that one. Soap is a base. It is 10, has a pH of 10, which is above 7, which makes it a base. Fantastic job, guys. So pH scale, a change of 1 pH, so going from 8 to 9, 12 to 13, represents a 10-fold change in the acidity of a solution. So for example, if one solution has a pH of 1 and a second solution has a pH of 2, the first solution is not twice as acidic as the second. It is 10 times more acidic. So if your pH went from 1 to 3, it is 100 times more acidic. It's called a logarithmic scale. Now, we are going to go back to our pH scale diagram, and we are going to do a lab. The lab today is called Let's Talk About Acids and Bases. And it's going to show up right on your, hopefully, PowerPoint screen under the Document tab. So you should see it. Some of the print may be a little small, but it is up on your Document tab, which is in the top right. So let's talk about acids and bases. This is an experiment with baking soda that makes acids bubbles. So if we put baking soda into an acid, it is going to bubble. If it does not bubble, it is a base. Foods that we eat are either acidic or alkaline. They're either an acid or a base. Today, we are going to test common ingredients used in baking to see what they do when baking soda is added to them. We are going to look at water, vinegar, some type of juice, and dairy-free or regular yogurt. If you're missing one of these 4 ingredients and you want to substitute it with something else, that's perfectly fine with me. what we are going to do before we get started is I want you to think in your heads, which ingredients do you think are acidic? And which do you think are alkaline or a base? So I'm going to, up on the whiteboard, write out our choices. And I want you to fill in whether you think it is an acid or a base. So our first choice is water. Do you think water is an acid or base? You can put either an A or a B in the water rectangle, or you can write the whole word. Now your juice. Now, depending what type of juice you have, maybe you'll get a different answer here. But tell me if you think the juice is going to be an acid or a base. Next, we have yogurt. Do you think yogurt is an acid or a base? And lastly, down in the middle, we have vinegar. Leave her. Leave her. So write acid or base or put an A or a B. We're making our hypothesis. Okay, looks like we generally, most of us, agree. So now we're going to do the experiment. Now, since my webcam is not working, Elizabeth volunteered to help us with part of it, and if someone else would like to help us, we can go ahead. You guys will switch off. So first we are going to switch to Elizabeth's camera, and what you guys are going to do is you need 4 glasses. In cup 1, you are going to put water, just a little bit. You don't have to measure the amount. Cup 2, you are going to put juice. Cup 3, you are going to put yogurt. And cup 4, you are going to put vinegar. So fill your glasses up for me, and once you have them full, you are going to click yes on the poll. Okay, if we look at Elizabeth, she's adding the ingredients or the liquids into her cups. So if everyone could go ahead and add their liquids in. If you're testing something different, that's fine. Add whatever 4 things you have decided to test. And then go ahead and click yes for me, please. Okay, you're filling up your liquids, and then you're clicking yes. You're not adding any baking soda yet. Okay, Elizabeth just looks like she dropped her yogurt in. So go ahead and finish adding and then click yes for me so I know we are all caught up to each other. There goes Elizabeth's vinegar. Okay, and when you are done, you can just click yes for me so I know who is done and who is still working. If you don't have the materials to do the lab, just go ahead and click yes so we do not wait on you. Okay, I'm waiting for 3 more people. Okay, if you're still adding your liquids, continue adding. We are going to go ahead and move on. The next step is you are going to add a tablespoon of baking soda to the water. When you add it, I would like you to watch what happens. You may see bubbles, you may not. You are going to probably want to stir once you add the baking soda in just a little bit if you're not getting bubbles, just to make sure you're really not getting any bubbles. So start with the water, since that's kind of control, and add 1 tablespoon of baking soda to the water, please. And watch what happens. Okay, would anybody like to describe what happened when they added their baking soda to their water? Go ahead and raise your hand if you want to tell me. Xana, go ahead. What happened in your water?
Nothing.
All right, nothing happened. That is what I would have expected. Now we are going to go ahead and take a tablespoon and add it into your juice. A tablespoon of baking soda into your juice and watch what happens, if anything. Would anyone like to share what happened in their juice? And tell me what kind of juice you have. All right, Shelby, what kind of juice do you have and what happened?
I have orange juice and it bubbled.
Awesome. Mallory, what kind of juice do you have and what happened?
I have apple juice and it's fizzing a little bit. Small bubbles are coming out.
All right, perfect. And Elizabeth, I can see yours is bubbling. What kind of juice do you have?
I was going to show you, but apple juice.
Awesome, apple juice. Great job. Did anybody have a different type of juice? Not orange juice and not apple juice. Okay. Next, we are going to try the yogurt. Go ahead and add a tablespoon of the baking soda to your yogurt. This one is going to be difficult, so go ahead and pay careful attention to what happens, if anything. Awesome. Would anyone like to describe what happened in their yogurt? Xana, go ahead. Oops, it looks like we lost Xana. Anyone else want to describe what happened in their yogurt? Shelby, go ahead.
I used my brother's and it bubbled.
All right, fantastic. And the last one that we have to do. Oh, go ahead, Xana, you're back. Go ahead and let us know what happened.
Oh, sorry, I logged out, but nothing happened.
All right, fantastic. Our last one is vinegar. Go ahead and add a tablespoon to vinegar and see what happens. I will caution you not to have this too close to your computer. Go ahead, Elizabeth, you're fine. All right. Oh, my goodness. Look at what happened to Elizabeth's vinegar. Does anyone else want to show me what is happening in their vinegar container? All right, Xana, let's turn your camera on first. Thank you very much, Elizabeth. Xana, go ahead and click the start button and your vinegar. Oh, we can't hear you talking, Xana. Make sure you click the talk button.
Oh, now I know how. Well, no, I'm doing it. But, it was like that high, almost up to full, where it almost hit and got up and exploded, but, it just stopped bubbling.
Awesome. Mallory, would you like to show us yours? Go ahead.
My vinegar has bubbled up a bunch and it made a big mess.
Fantastic. Great job, Shelby. Go ahead and show us yours if you would like. Let us see what happened in your vinegar cup. Oh, we can't hear you, Shelby. Make sure you click your talk button.
My vinegar one, when I did it, I already did it though, since my thing was so small, it bubbled out.
Oh my goodness, crazy. Great job, guys, and thank you for everybody who shared their video screens with me today. Go ahead, Xana, you have a question? Go right ahead.
My yogurt just started bubbling.
Awesome. So we have a newly bubbling yogurt. Maybe everybody should take a look back at their yogurt and see if it is doing anything. Check it out. Go ahead and give me a smile face if your yogurt started to bubble. Go ahead, Mallory. What would you like to share?
My vinegar was filled all the way up to the glass, and now it's less than halfway down to the bottom.
Great observation. All right, so we had 4 different liquid substances that you guys tested. Some were acids and some were bases. You guys made some predictions on the whiteboard. I'm going to pull back up before we started. Now, based on your results, ready? I'm going to draw a line down each of these. On the right-hand side of each square, I would like you to write your actual results. So whether you had an acid or a base. So let's think about this. How are we going to know? You don't see my whiteboard screen, Mallory? How are we going to know what is an acid and what is a base? Go ahead, Xana.
Because acid bubbles and bases do not.
Very good. So with those results, I need you to go ahead and fill in your chart. Acids bubbled, bases did not. So for example, for an vinegar bubbled for me. So that means it's an acid. So over here, I'm going to write, I don't need to write the whole word, but I can. I'm going to write acid, because vinegar is an acid. So go ahead and fill in your results on the whiteboard for me, please. I just unlocked it, so I just unlocked it, Elizabeth, so you all should now be able to type. Now, everyone's results are not going to be identical because some people used apple juice, some people used orange juice, some people may have used different types of yogurts. So I want to see your results up, not what you think you should have gotten. Did Daddy make you guys? Go ahead, Mallory, you have a question?
My thing at home, I experimented with it a little, and I couldn't really see the baking soda swirl. But when I put this green food coloring in there, and it's swirling like that, and in the water, it didn't really bubble. And I put it in there, and it didn't do anything. And it looks like the baking soda is doing a reaction to the vinegar.
Okay, those are some great observations. And that's the type of observations that a really good scientist can make. Probably, Brianna, it probably means it's acidic. It got a whip-like consistency. Air was being added into it, probably from bubbles. There's a lot of variables in this lab. Some of the variables could be how old your baking soda is. The older your baking soda is, the less reactive it's going to be. Definitely the type of juice you use, the type of yogurt you used. If you used strawberry yogurt, you're also going to have a little bit of, is strawberry acidic or basic? They sell different percentages of vinegar. So if you had a higher concentration of vinegar, you would get more bubbles. We also have water. Depending on where you live, if you live in a city that has city water, the pH of your water should be 7. However, if you have a well like I do, the well water coming out of my well is just about 6. So that means the pH of my water is different than the pH of your water. So there's lots of factors that can go into this lab. However, it's a great thing for you guys to just look at the observations that you can make and the differences between acids and bases. So, I hope you guys enjoyed today's class. It was a fun one. You do have a short little homework assignment that I put up on the Moodle website. It's just asking you to come up with an acid and base and do a little something with it. Go ahead and take a look at it. Just a reminder, we will not have class next Monday. I am going to be out of town. Our class is going to be made up next Friday. So in a week and a half today, on February 20th, we will have class from noon to 1 p.m. I hope you guys have an awesome day and an awesome rest of the week. And if you're in the Northeast like I am, we're getting more snow. So it looks like I'm the only one up this far. I don't know if you guys are getting it down in Maryland and Virginia and Washington, but we are supposed to get another 6 to 8 inches of snow today. So I hope you all have a great day and enjoy. Xana, go ahead. Do you have a question?
We are in Florida and we have a lot of sun.
Well, I am very jealous of a lot of sun that you may have in Florida because I have some shoveling to go do this afternoon. Shelby, go ahead.
I'm in the desert and I don't even get snow.
All right. Well, I hope you guys have a great day and enjoy the rest of your day. Thank you for your patience, and thank you, Elizabeth, for sharing your camera with us. Have a great afternoon, everyone.